So welcome to the class, beta, all of you. See, we are going to discuss in continuation only. We are talking about motion along a straight line. It means one-dimensional motion. It means any one coordinate out of the three coordinates x, y or z can be considered, as we have already discussed about motion in one dimension. Today we have to discuss with you about the relative velocity with which one object is moving with respect to the another object. That velocity we will be calling it as the relative velocity. Or we may say that it is defined as the time rate of change of relative position of one object with respect to the another. Because till now we have discussed about the speed and velocity in very detail. Now what we want to study is that how one body is moving with respect to the another moving body. It means both the bodies are in motion. Like if you are sitting in a train and you are simply observing the motion of the another train, both the trains, they can move in the same direction, they can move in the different direction. So that we have to study in detail today, but of course restricting ourselves to one dimensional motion. I'm saying first case with me that two bodies are there, A and B, and they are moving in the same direction. Like you may take two cars, two trains, or you are moving on any other vehicle, you can consider yourself, or simply you are moving. So what we have taken first case that this is first body is moving with velocity VA. I'm trying to put the vector sign because velocity is a vector quantity on it. That is simply by a line along with an arrow. That is compulsory to write for all the vector quantities we will be using throughout the 11th class. And of course we will be studying about the vectors in detail also in the coming lectures of it. But for now you keep it in mind that for every vector quantity we are putting a sign, a line with an arrow, which is a sign to denote the vector quantity. Now what I am saying is that VA is the velocity of the first body, A body, which is of course shown in the diagram to its right along the x-axis only, positive direction. Similarly, VB is also moving along the x-axis, positive direction. This is my supposition, both are moving in the same direction. So they are shown by the parallel lines, or they can be shown along the same line. That is simply because we are talking about the one dimensional motion. So you can even draw on the same line, both are moving. Just to make the things clear, I have shown by the parallel lines, because if we are showing along the parallel line, still the axis or the line is same, only I have changed to the reference point for me. Now what I want to see is, I want to find the relative velocity of A with respect to B, with reference to B, with reference to B. It means I am here sitting in B train and I want to observe the motion of the A train. So for simplicity, this always you can do, whatever body with respect to which you want to study, bring that body to rest. If I want to bring this VB to rest, it means I will be adding negative of VB to it. But if I don't want to change my equation, then the same value I will be adding to VA also. So it means VB is in the positive direction, so VB negative will be in the opposite direction, means minus x direction. So as a result, VB will come to rest, and then this result will come VA minus VB, because both are in the opposite direction. So this is the formula with you when both are moving in the same direction. VAB can be written simply by bringing the second body with respect to which we are finding the relative velocity to rest. It means the formula becomes VA minus VB. Similarly, if I want to find the relative velocity of B with respect to A, it means I have to bring A to rest. So I will be adding minus of VA to this. So same minus of VA is to be added to B body also, to not to vary the equation. So as a result, I am getting VBA, which is the relative velocity of B with respect to A, it comes out to be VB minus VA, because A will come to rest, and as a result, resultant value for this body will be VB, and VA is in the opposite direction, so VB minus VA. Opposite direction is simply shown by the negative sign. Now, if I am taking the second case with me, I am saying A and B are in opposite directions. So, it means A is along the positive direction plus, and the second body moving with VB velocity is in the opposite direction towards left. So, negative direction. So, now if you find VAB, that is of course bring the B at rest with respect to B, we are finding VAB is velocity of A with respect to B. So, bring B at rest. For bringing B at rest, I have to add minus VB to it. Minus VB, it means in the positive direction it will come, because VB is in the negative direction. So, plus negative of VB will be in the positive direction. So, VA, and here also if you put VB, it will come in the positive direction. So, as a result, my result is coming VA plus VB. But this I may write from my this formula also, because I have simply changed the direction of second body VB. So, in place of VA minus, you can write it VA minus of minus VB, which is coming out to be VA plus VB, or you can write this formula directly by simply bringing the second body at rest. That is your choice. So, for when it means A and B, they are moving in opposite direction, then the velocities are to be added, that is VA plus VB. Similarly, if you want to find the relative velocity of B with respect to A, then again you have to bring A to rest. So, A to rest, you have to add this V minus of VA to this, it means negative direction of velocity of A. So, this negative will become the positive value for B value, but of course the resultant will be towards left. For this case, resultant will be towards right. So, that you have to take care in the numericals whenever you answer, that it will be in the positive of x direction, it will be in the negative of x direction. So, these are the formulas to solve the numericals. Whenever the velocity of two bodies are given to you, you can directly use these formulas. But of course, we can velocity in terms of the displacements also, in terms of the position vectors also. Like if I am supposing that initially the body is first body is at 0 position, which is written as xa naught, and moving with the VA velocity for time t, then finally it reaches at the position xat. Then for the uniform motion, because we are assuming the bodies are moving uniformly, so for the uniform motion, we know the formula that xa minus xa naught is equals to VA into t. So, you can write this equation by the definition of the velocity, that is displacement upon time. So, xat minus xa naught divided by t will be equals to velocity, or I can write xat equals to xa naught plus VA t. Similarly, you can write for the second body xb at time t, it is equals to xb at time 0 plus vb at time t. And when you subtract the both, you are getting xbt minus xat equals to xb naught minus xa naught plus vb minus va into t. So, this is the relative displacement at time t, this is the relative displacement at time 0, and this will be of course the relative velocity. So, Vb minus Va is the relative velocity, that from this equation also I can write, that is velocity of B with respect to A. If you want to understand the things with the help of graph, like if I say that two bodies A and B, they are moving with equal velocities, then slope of the two lines has to be equal. When I plot the xt graph, then slope of A and slope of B will be same. It means you can get the parallel lines which will never meet each other, because both are moving with equal velocities. But if they are moving with unequal velocities, So then the slopes will be different, of course. If VA is greater than VB, it means slope of A will be more than slope of B, that you can see, and then A will meet B at any point. That meeting position will be there when the speed of A is greater than speed of B. But if speed of A is less than B, then slope will be of course less, then they will never meet each other. They will keep moving apart with the passage of time. So graphs can be shown like this. Depending upon the magnitudes of the velocity, you have to draw the graph, xt graph, that is of course the position time graph, and you all know that slope of position time graph gives you the velocity or speed. So speed in a given direction only is termed as velocity, that also you all know. If I ask that the position time graph of the two bodies which are moving in the opposite directions, it means then one graph you will be showing this way, coming in the opposite direction, negative direction. This is moving in the positive direction. So then they will always meet at any point. So on that basis, you may come across the various questions related to the relative velocity. You should be able to work out. Here is a question with you, that a jet cruising at a speed of 1000 km per hour ejects hot air in the opposite direction. It means jet is moving in the upward direction, if I say, then the hot air is moving in the downward direction. If I am saying that jet is moving in the x direction, then the hot air is moving in the minus x direction. That is, you can choose whatever comes to your mind first. So one is in the x direction, another will be in the minus of x direction. So if speed of hot air with respect to jet, they are saying speed of hot air. If I say that jet is A and hot air is B, then it means they are giving you VBA. Hot air with respect to jet is 800 km per hour. So because I am supposing jet is moving in the positive x direction, so hot air is moving in the negative direction. So this VBA will be negative of 800 km per hour. But VA is given 1000 km per hour. Then you have to find VB. So you can simply use this formula of relative velocity, that is VBA, it is equals to VB minus VA. And from here on solving, you will be getting the velocity of the second body. It means velocity or speed of the hot air. Speed means only magnitude they are willing to get, but of course velocity is a vector quantity. So whatever question comes, accordingly you people can write. So this is the magnitude they are asking, which is coming out to be 200 km per hour. Next question with you is, if two bodies, they are at constant speeds, they are moving towards each other, then the linear distance between them decreases at 6 km per hour. If the bodies move in the same direction with same speeds, then the linear distance between them increases at 2 km per hour. So if I am taking speeds are u and v and they are moving towards each other, then the relative velocity will be, because towards each other it means opposite direction. So speeds will be u plus v, or you can use the formula of relative velocity and then you can get it by, otherwise simply also you can write, because when they are coming towards each other, it means they are moving in the opposite direction. So VAB will be given as u plus v, which is they have given you 6 km per hour. And when they are moving in the same directions, then the relative velocity will be equals to VA minus VB, which is equals to u minus v. These formulas we have done, so you can use these formulas directly also. And when you solve these two equations, you are getting that u is coming out to be 4 km per hour and v is coming out to be 2 km per hour. Simply by adding these two equations, you will be getting 2u equals to 8. They have specially mentioned also that find the speeds in kilometer per hour. So it means no need to convert in this particular question. But otherwise, if they ask you to give the result in meter per second, then you have to convert. And if they're silent about it, that you have to simply find the speeds, then it is your choice. You give the answer in kilometer per hour or you give it in meter per second. Then it will be totally your choice. No marks will be deducted for that thing. This is the last question with you. They are saying two cars initially which are at the separation of 12 meter. They start simultaneously. First car A, starting from rest, moves with an acceleration of 2 meter per second square, whereas the car B, which is ahead, is moving with a constant velocity 1 meter per second along the same direction. Find the time when car A overtakes car B. First car is at rest. So if I want to write the relative velocity of A with respect to B, which is equals to VA minus VB, then VA is given rest 0. And here's VB is moving with 1 meter per second. This is given in the question. You need to read the question carefully. Then it means I am getting VAB is equals to 0 minus 1 means minus 1 meter per second. Relative velocity. Similarly, if you want to find the relative acceleration A with respect to B, which is equals to AB, which is of course by the formula it is equals to A minus AB, then acceleration of A is given 2 meter per second, while B is not having any acceleration because they are saying it is simply moving with constant velocity. So when velocity is constant, it means acceleration is 0. So you are getting 2 minus 0 means 2 meter per second. Now I want to find the time, but the distance is given 12 meter. They are at a separation of 12 meter when they start. So you can simply apply the equation of motion, second equation of motion, assuming that second body is rendered stationary, means what, assuming with respect to B we are finding, then B is taken at rest when I am writing VAB or I am writing acceleration AB, then of course I am assuming B to be at rest. So I can simply use the relative values in the second equation of motion. Like this is the equation with you, x equals to ut plus half at square, then x is given 12, u means again the relative velocity we are taking, that is minus 1, and a is the relative acceleration, that is 2, and you have to put the values. You are getting t square minus t minus 12 equals to 0. You can work out with this quadratic equation, that is t square minus t minus 12 equals to 0. You know how to work with the quadratic equation. So we are writing t square plus 3t minus 4t. This is of course giving you minus 1t minus 12 as it is. And so you are getting t plus 3t minus 4 equals to 0. And we are simply ignoring the negative value and we are getting the answer t equals to 4 seconds. So this is all for today we are talking about. Thank you everyone.